Hi guys, so in this video, we are going to explain the meaning of differentiation, the techniques of differentiation, and answering some question given by applying the techniques of differentiation. So without further ado, I'm going to explain the meaning of differentiation for you guys to have better understanding about this topic. What is differentiation? So differentiation is a method used to compute the rate of change of a function f(x) with respect to its input x. So this rate of change is known as the derivative of f with respect to x. Now let's move on to techniques of differentiation. There are 6 techniques of differentiation. Let's go one by one with me. The first technique is derivative of constant, linear, and power function. So for constant function, when you differentiate, you will get 0. For linear function, when you differentiate, you will get the coefficient number itself. So for the slide, you can see it's 8. And lastly, the power function, when you differentiate, the power will times with the coefficient of x, and the power will subtract with 1. The second technique is derivative of sum and difference. So these techniques used when all the derivative you want to sum with each other or subtract with each other. For example, derivative of sum f prime x plus with g prime x. An example for derivative of difference f prime x minus with g prime x. The third technique is product rule. So product rule is used when two functions are multiplied by each other. Formula, which is dy dx equals to uv prime plus with vu prime. The fourth technique is quotient rule. So quotient rule used when two functions are divided by each other. The formula of dy dx equals to vu prime minus with uv prime over with v squared. The fifth technique is chain rule. So chain rule is used when a function is inside another function. For example here, the gx is inside the function of fx. So using the chain rule, we have to differentiate the outer part first. So differentiate the function of f, and then second, we differentiate the inner part, which is gx. So when you differentiate, you will get f prime gx times with g prime x. And lastly, the sixth technique is derivative of trigonometric, exponential, and logarithmic function. So let's go one by one. Derivative of trigonometry, for example here, is when you differentiate sin x, you will get cos x. And when you differentiate cos x, you will get negative sin x. And the other example you can see on the slide. Next, derivative of exponential function. So for exponential, when you differentiate e power x, you still will get e power x. And lastly, derivative of logarithmic function. So for derivative of logarithmic function, for example here, we have y equals to ln x. So differentiate ln x, you will get 1 over x. But for this other example, which is y equals to ln fx, or this example is actually a combination with chain rule. So chain rule, we will differentiate the outer part first and then differentiate the inner part. So we differentiate the outer part, which is ln. When differentiate ln, we will get 1 over fx times with differentiate the inner part of function, which is fx. So differentiate fx, we will get f prime x. So the final answer is 1 over fx times with f prime x.
Hello guys, let's look at question 2a. We are asked to differentiate the function y equal to 9e power x times tangent in bracket x minus 3 close bracket. Since this is a product of two functions, we will apply the product rule. The product rule states that the derivative of dy over dx is equal to vu prime plus uv prime. So first, we identify our two parts. Number 1 is u equal to 9e power x, and the second one is v equal to tangent in bracket x minus 3. Now we differentiate each part. The derivative of u equal to 9e power x is u prime equal to 9e power x. This is special case because the derivative of ex just ex. For v equal to tangent in bracket x minus 3, we use the chain rule. The derivative of tangent is secant square, and it will become the secant square in bracket x minus 3. And since the inner function is x minus 3, the derivative is 1. So we multiply with 1, and we will get the answer. Final answer is v prime equal to secant square in bracket x minus 3 close bracket. Now we substitute into the product rule formula. We get the 9e power x for both terms. So we factor it out to simplify it. Then we get the final answer is dy over dx equal to 9e power x, open bracket, tangent, open bracket, x minus 3, close bracket, plus secant square, open bracket, x minus 3, close bracket, and close the final bracket. Okay, let's move on to question 2b. Here, we are asked to differentiate y equal to x squared plus 1 over sin x. Since this is a fraction, we will use the quotient rule. The formula of quotient rule is dy over dx equal to vu prime minus uv prime over v squared. First of all, we identify the two parts. The first one is u equal to x squared plus 1, and the second one is v equal to sin x. And then we differentiate each part. The derivative of u equal to x squared plus 1 is u prime equal to 2x. The derivative of v equal to sin x is v prime equal to cos x. Lastly, we substitute into the quotient rule. We get dy over dx equal to 2x times sin x minus x squared plus 1 times cos x over sin square x. This is our final simplified answer for question 2b. That's all from me. Thank you.
I will explain how I differentiate the equation given 1y plus sin the power of 2 in bracket x to the power of 2 plus e to the y equals to 5xy. First, I bring the power of 2 to the back, and because the equation has both x and y, I use implicit differentiation. This means every time I differentiate a term of involving y, I must multiply by y prime. First, I differentiate the ln y. I differentiate it using a change rule. The derivative of ln y is equal to 1 over y. Inside we have y, so the derivative of y is y prime. Then I differentiate the second term. This also use change rule. First, I bring the power of 2 to the front, and the power of 2 minus with 1 equals to 1. The derivative for sin is cos. Inside we have x to the power of 2 plus e to the y. I differentiate each part of this, and the derivative of x to the power of 2 is 2x, and the derivative of e to the y is e to the y prime. And then I differentiate the right side also. This one is product rules because it have two variables. The formula of the product rules is vu prime plus uv prime. And after I calculate it, we get y plus xy. And then these two I multiply with 2x plus e to the y prime. And then we write it back down, 1 over y prime plus 4x plus 2 e to the y prime since x to the power of 2 plus e to the y cos x to the power of 2 plus e to the y. The 5xy, we need to bring it to the left side because we want to get all the y prime on the left side only. So we write others back down, and because of its positive, we bring it to the left side, it will become negative 5xy prime. And then we factorize the y prime, and we factorize the y prime, it becomes y prime in bracket 1 over y plus 4x plus 2x to the 2e to the y since x to the power of 2 plus e to the y cos x to the power of 2 plus e to the y minus 5x equals to 5y. So my last answer is y prime equals to 5y over, and this equation I bring it to the right side since it multiplies, bring it to the right side, it will become divided. So 5y over 1 to the y plus 4x plus 2e to the y since x to the power of 2 plus e to the y cos x to the power of 2 plus e to the y negative 5x, and this is our last answer.
And for the last question in this video is we have to use linear approximation to estimate the value of 8.02 square minus with cube root of 8.02 correct to 2 decimal places. In this question, they ask us to estimate and by using linear approximation formula. So let's get right into it. First thing first, we have to list down the linear approximation formula, which is f x naught plus with delta function x equals to f x naught plus with f prime x naught times with delta function x. After we write down the formula, there are 4 steps that we need to find before solving the question using the formula. So the first step is the value of x and x naught. So what is x? X is the given value from the question, and x naught is the chosen value that we choose ourselves. And for second step is we have to find the delta function x, which is equal to x minus with x naught. Third step is we have to let fx, and the fourth step is we have to find f prime x. Without wasting any time, let's solve the question. So first, write down the linear approximation formula, then find value of x, which is the given value from the question. So the question gave 8.02, so our x is 8.02, and our x naught we have to choose ourselves. But how? We are going to choose by choosing the closest number to x. So the closest number to 8.02 is 8. The second step is to find delta function x, which is x minus x naught. So 8.02 minus 8 equals to 0.02. And the third step is we have to let fx. So for this one, we have to follow the equation. So the equation given is 8.02 square minus cube root of 8.02. So the 8.02, you just substitute with x. So our fx, you will get x squared minus cube root of x. To simplify it more, the cube root of x, we will change it into x to the power of 1 over 3. So fx is equals to x squared minus x to the power of 1 over 3. And lastly, the fourth step is to find the f prime x. So just differentiate our f prime x, will get 2x minus 1 over 3 x to the power of 2 over 3. So to make it simplify, we are going to move down the x to the power of negative 2 over 3 and to down. So it will become, our f prime x will become 2x minus 1 over 3 times with x to the power of 2 over 3. So f bracket 8 plus 0.02 equals to f bracket 8 plus f prime bracket 8 times with 0.02. 8 squared minus with 8 to the power of 1 over 3 plus with 2 times 8 minus with 1 over 3 times 8 to the power of 2 over 3 and times with 0.02. So when you calculate, you will get 62 and 0.32. Actually, the answer in the calculator they give is 0.31833. But because of the question 1 in 2 decimal places, so we're just going to take until 0.32. Final answer, you will get 62.32.